Thank you so much for joining us today as we present to you the UTD Comet Shuttle Service. This is a project that was developed over the course of the fall 2015 semester in order to present UT Dallas with a satisfactory mechanism to help students navigate campus. The presentation today will cover quite a bit about our project. Specifically, we'll walk you through sort of our motivation for the project, some of our solutions, and then share with you some of the design and some of the implementation features that UTD could expect as we move forward. You'll get a chance to see the prototype of the interface as well as some of the design decisions that we've made on the back end to help you understand the breadth of our project and what we hope to accomplish. UT Dallas is a campus that's currently under a great transformation. Over the past 10 years, they've seen 124% growth in enrollments, totaling over 24,000 students. They've built 4 new residence halls with 5,000 students currently living on campus, and overall have completely transformed the type of commuter campus that they were to the type of residential, more traditional university in which has a robust residential population. As part of this growth, what has been lacking is sort of allowing students easy transportation throughout campus. Current conditions include a UTD service that's called the Comet Cab. It's a small golf cart type of system. It runs 5 different routes throughout the campus, and each of these routes have their own hours of operation, and they can change frequently due to campus events or weather conditions. There are also no stops that are currently specified on the route. Riders are asked to actually step into crosswalks and try to wave down a shuttle. And with all of this kind of volatility around scheduling and what they are, they're just not being utilized in a way that benefits students or that benefits the investment that the university's made in this service. And so it is our hope that the Comet Shuttle solution that we've developed will help address some of these concerns. The Comet Shuttle solution that we've developed really takes the guesswork out of where the shuttle is and how do you stop it, really out of the equation. What we've developed is an application that can be run on a mobile or a desktop device that allows the users to monitor the progress of the shuttle real time. So they'll actually know where the shuttle is throughout each of their 5 routes and can make decisions regarding transport accordingly. They will also be able to get updates from drivers. So if there is, for some reason, a delay, or if there is something that's sort of impacting the shuttle route, the application will actually highlight those updates in a real-time sort of chat window type of device. Also, because this is such a new concept for the university and a new service, we'd like the ability for users to be able to share with us their experiences of riding the shuttle. Also kind of help build a word of mouth little activity and help sort of the students and the rest of the population of campus get involved in riding the shuttles and, you know, kind of seeing that return and maybe seeing parts of campus they haven't seen before, or doing maybe some of the other events that are located throughout campus that the distance has sort of been a obstacle in the past. So we do hope that this project will sort of allow the users and the riders to sort of take control over the system and be able to make their plans accordingly. The Campus Shuttle program is something that can be implemented with a relatively low investment. The university has already purchased the golf carts that run the current 5 routes. What we're talking about adding is the GPS systems as well as perhaps some training to the drivers. But in essence, all of the equipment and all of the manpower is already in place. The Comet Shuttle system is actually something that runs sort of on top of these existing programs, leveraging the technology that the riders already have in their hands, and really capitalizes on that and allows for that real-time update and those real-time monitoring.
Here is our business process model, which is a simplified flow of our process. As you can see, there are kind of 2 starts. The driver will enable the GPS for the shuttle and then proceed to drive the route, while the user will open the app and select a route that he or she decides to look at, and that request is sent to the app, and the corresponding data is then displayed to the user with the GPS location and everything. The user is then able to provide feedback on whether or not the shuttle is late, the conditions over there, which is displayed to all the other users of the application. And also the driver can provide feedback as well, saying that they are late or something has happened and the shuttle will be delayed. And both of these are optional. And then that is the end of our business process.
The context diagram for our proposed UTD shuttle system provides a high-level overview of how the required external entities interact with the application. The user will make a route selection via the user interface, and the result is displayed back to the user. This is provided by the route dataset located within the application. The user also has the ability to enable real-time updates provided by other shuttle users and shuttle drivers as well. The updates can include route adjustments, road hazards, vehicle failure, and any other reason the shuttle would be delayed. The entity live update is simply another shuttle user who provides the real-time updates to the application for all users and drivers to utilize. The shuttle drivers perform the task of activating their GPS tracking devices and retrieving their route schedule from the application. The drivers can also both provide and receive real-time updates from the application. Lastly, Google Maps provides all pertinent map information to the application for use by all other entities. The use case diagram is another simple representation of all users and how they interact with the proposed shuttle application. You can see that both the users and the drivers must log into the application prior to accessing its features, which will assist us in identifying and tracking their activity. As discussed in the previous slide, the users and drivers can both provide and receive real-time updates to the system, assisting each other in helping to make a more transparent and efficient shuttle program. Google Maps will provide map information to the system on a continuous basis, which will be accessed by the driver once the GPS has been activated. Additionally, once the driver's GPS has been activated, the user may now retrieve the approximate shuttle location on their chosen route.
The complete class diagram displays all of the classes that we have created for our application. As you can see, there is user, driver, shuttle, routes, and location classes, with the associated attributes such as location ID, location name for the location class, driver ID, driver first name, driver last name for the driver class, and so forth and so on. There is a one-to-one cardinality between driver and shuttle because the driver will only be driving one shuttle, but there's a many-to-many relationship between user and routes because a user can display all of the routes or none of the routes, and the routes are accessible by all of the users or none of the users, depending on if they decide to use the application or not. The shuttle will be driven on all of the routes depending on what the schedule is, or none of the routes depending on if it's out of commission, and each route will have at least one location, but will probably have multiple locations. The sequence diagram displays the sequence of events that occurs after the select route is triggered, but we also have additional information, such as the driver activates GPS location with the GPS system, and the driver requests the route schedule from the route dataset. The user logs in and the system accepts the credentials, and then the user makes route selection. That request is made to the route dataset, which is returned and displayed to the user. And the user then selects a route, and then that request is sent to the GPS system, and the location of the shuttle is returned and displayed to the user. Our database design was based off of our class diagram, so you will notice a few tables that are similar, such as user, driver, route, shuttle, and location. But because of the many cardinalities that we had to create a few bridge entities such as selection, has, assign, and list. Primary keys are identified by the PK, and foreign keys are identified by FK. And as you can see, a user will make a selection to one or many routes, and the route has a list of locations, and the route also has a shuttle, and the driver is assigned to a shuttle. So that is our database design.
Now I will walk you through the interface design. This basically gives the look and feel of the UTD Comet Shuttle Service app. This is the registration page where the user is asked for the first name, last name, email, and password, which are then stored in the database for future validation. Every first-time user needs to register here, and no guest mode is available in our app. Moving on to the login page. A returning user can provide their email and password with which they had registered earlier. The app then checks these credentials with the ones already stored in the database and provides access if it matches. Next is the interface diagram for the real-time tracking and navigation. As you can see here, on the left-hand side of the screen is a map which shows 5 different routes in different colors. It has pins which shows the location of the shuttle, and you can also track the shuttle and its direction. On the right-hand side, there are options provided to choose any route, choose all the routes, or choose none of the routes. There is a chat window which updates announcements from the drivers regarding any delays about the schedule or so on. Also, users can tweet and provide feedback, which is also available to be viewed by everyone. Here is an example where a user just chooses one route and only that route is highlighted. You can also see the direction in which the shuttle is moving. A user can download this app on their laptops, desktop computer, iPads, or their mobile phones. Here is the design for the mobile view of our app.
It is our hope that at this point in time you can see that the Comet Shuttle system is something that's going to add a great value to the student population by regularizing the stops, the timing, and allowing the users to see the shuttle real time. It will allow the students to kind of navigate campus quicker, to do it in a reliable and safe fashion, and perhaps allow them to experience parts of campus that they have been avoiding before. Also, you can see that this is a project that is coming to you with very little investment and is something that can be easily deployed and then customized as you start evaluating the feedback from the students and the riders to see what other enhancements they might like, or as you see the participation in the program grow. So we want to thank you so much for your time today. We think we've put together an outstanding program for you, and we're excited to see where the Comet Shuttle program goes.